All right, we are going to get started with lesson 3. We're going to skip over combinations for right now. Biggest thing I want to go over next is going to be the concepts of probability. All right, um, when we deal with probability, this is going to be mainly when people start thinking of like getting the odds of something to happen. So think like gambling, uh, kind of things, uh, games of chance ish. So that's what probability is. So I'm going to give you a chance to write some of this stuff down, and then I will begin to talk about it. All right. So for probability, with these probabilities, we usually refer to them as experiments. All right. So with a probability experiment, it's a process that's going to lead to well-defined results and outcomes. Meaning, if we are able to do this experiment over and over and over again, it's going to give us results that we should expect to happen pretty much every time. Okay. Um, so that's kind of what the probability experiment is. An outcome is going to be the actual results of a single trial. Okay. Uh, so again, like that'd be like flipping a coin. We're going to have one of two things that happens. It'll either land on heads, it'll land on tails. Okay. If you roll a die, it's going to go and land on a 1 through a 6 if it's a 6-sided die. Okay. Um, and we're going to kind of talk some of those ones, but that's what an outcome is. It's the actual result of one of those trials. And the last one, when we start putting it through, is going to be a sample space. That's going to be the total amount of outcomes. Okay. So when you do that experiment, how many total outcomes are there going to be? So I'm going to kind of talk these experiments and the sample space that we have. Okay, I already mentioned the rolling or tossing a coin. It can land on head or tail. So the experiment is tossing the coin. The sample space, it could be two different answers. It could be a head or it could be a tail. So we've got two specific answers that it could be in that sample space. Actually, let me get a different color so you can kind of see the difference. All right, so tossing a coin, you have two options. When you roll a dice or roll a die, okay, it can land on a 1, 2, 3, 4, 5, and 6. So my total sample space will be all 6 of those, or I've got 6 options to go from. Okay, if there's a true or false problem, it can either be true or it can be false. So we have 2 options. Now, if I'm going to flip 2 coins, I have a total, excuse me, I've got a total of 4 options. I could have both of them land on heads, both land on tails, one land on head, one land on tail, one land on tail, one land on heads. I've got 4 total options of how it could land. Okay, so that's what that sample space is. Usually, whenever we're dealing with this stuff, the sample space will be like that bottom number that's on the fraction itself. Okay. On to my next definition, kind of the last big definition that we'll have for a while, is going to be an event. Event is going to be that subset of the sample space. So it's usually the top number that will be on there. So like the event, if I'm going to say tossing a coin, the event that I want is that it's going to land on heads. So out of that, there's only one choice that it could be on that one. That's that event. Okay. So we'll look at this very first example here. Okay, our experiment, our sample space, and then our event. Our experiment is going to be drawing a card. Okay. So if we didn't have all of this stuff right away, we have a regular deck of cards. In a deck of cards, there are 52 cards. We're not counting the jokers. Meaning my sample space, my bottom number for that entire thing is going to be 52. It's trying to tell me that it wants to find the event So the probability of drawing an ace. So the probability to get an ace. Well, now I'm going to think through that whole entire deck of cards. Out of those 52 cards, I need to figure out how many of them are going to be aces. Out of those 52 cards, I will have 4 separate aces. Okay, so if I'm looking at my probability here for my event drawing an ace, and my sample space is 52 cards, my probability of drawing an ace is going to be 4 over 52. Or to simplify that down, the probability of drawing an ace in a deck of cards is going to be 8%. Okay. So on that one, that's kind of where the basic probability experiment itself. Okay. I'll kind of explain this one as we get through, or as you look at it. But we're going to talk classical probability. Okay, not theoretical, not something that, or sorry, not experimental, not stuff that we're actually going to do, but like the classical probability of like what we would expect to happen. Okay. So you will see the formula that looks like this, and I want to make sure I explain what this stuff actually means. Okay, whenever we have E, that's going to stand for the event. That's going to be that top number of the fraction. So how many total options am I looking for? Okay. So that's going to be the total amount of outcomes that we want to happen. And then the N of S, or the S that we're looking at, is going to be the total amount of outcomes in our sample set or our sample space. So meaning the total potential outcomes that we could have. Okay. As the math gets a little bit more advanced, they tend to use a little bit fancier descriptions. But again, simplifying this thing down, this stands for your probability of something. We put whatever we're looking for, is going to be the total outcomes down here over your positive outcomes, or yeah. So our positive outcomes there. Okay. And so that's where it kind of says down here, where it says one key assumption that we make is that every outcome in the sample space is likely equal. Okay. We're not accounting for the odds that it's happened before. We're not looking at anything else. We're trying to say, just looking at it, it's a 50-50 chance to flip a coin and have it land on heads. It is a 1 out of 6 chance to roll a dice and have it land on any one number. Okay, we're not going to look at, let's say how heavy one side is, or like if it's gone a little bit more often one way over the other. We're just looking at if every outcome is equally likely to happen. Okay, so on to some examples that we have here. Okay, I'm going to start looking at this die. We're going to roll the die. We're going to try to figure some stuff out. So for this first one, it says, what is the probability of us getting a 2, the number 2? So with a die, zoom in a little bit, with a die, I've got 6 possibilities. No matter what, it's going to have a chance of 6. Okay, and now if I look at that, I need to try to figure out on that die how many sides are a 2. Well, there's only one side that has a 2 on that die. So my probability of rolling a 2 on that die is going to be 1 out of 6, or simplified down, I've got a 17% chance that it's going to be a 2. I'm going to get a little bit trickier on these ones. This next one's going to say, what's the probability of a number less than 5? Again, I'm going to put probability less than 5. I have no idea what's happened to the screen right now. Let me see if I can make that thing go back up a little bit. I have no idea what happened. The probability of less than 5. If I do that, my bottom number is still going to be the same. It's still going to be a 6. I need to figure out how many numbers are less than 5. All right. I've got 1, 2, 3, and 4. I've got 4 total options of things that are less than 5. And my screen is currently possessed. But yeah, I've got 4 out of 6 that are going to be less than 5. So if I do that, I've got a 67% chance, or 66.6 repeating forever percent chance that I'm going to get a number that's less than 5. Let's see if I can figure out what's going on with this screen. Put my keyboard back on, see if that helps it. All right, next one, I'm going to look at what's the possibility or probability of getting an odd number. All right, if I'm looking at that dice, I got to put probability of an odd number. What is going on? Probability of an odd number. Bottom number is still going to be 6. All right, the total odd numbers, I've got a 1, 3, and a 5. I've got 3 options there, which tells me that my probability is a 50% chance of getting an odd number. All right. Next one, if I'm looking at coins, I'm going to toss 2 coins. If I toss 2 coins, my probability, I can get a chance of getting heads, 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 tails, tails and heads, and then tails and tails. That is really getting annoying. Hey, those are my choices there. Let's see if that stops things from moving. So looking at all my choices here, I've got 4 total options of the way it could land. So my bottom number is going to be 4. If I'm just looking at that, trying to figure out what my probability of getting 2 heads is, I've got 1 out of 4 or a 25% chance. Holy buckets, that's getting annoying. All right, let me see if I can do something to fix that. All right, next one. At least 1 is going to be a heads. So same thing. My bottom number is going to be 4. All right. And now I got to figure out at least one of them is heads. This top one has a head. That one has a head. This one has a head. I've got 3 options here of things that are going to be heads. So I've got 3 out of 4, 75%. Okay. I am going to be done writing on the top because it's getting way frustrating looking at that stuff as it keeps on moving on me. So I'm going to read onto the facts about probability, and then we'll get into the kind of the very end portion of this stuff. I'll give you a chance to kind of look at some of this stuff. You want to write some of those ones down. Mainly the first 2 are the ones that I'm most concerned with. Okay, so when I'm looking at those facts about probability, both of the events that happen and the samples that happen, or the sample space that happen, they have to be 0 or positive. You can't have a negative number. You can't have an option that it's potentially a negative chance that something's going to happen. Okay? So no matter what, it has to be positive or a 0. Next one, there can't be more outcomes in any event than any entire sample space. So the top number has to be equal to the bottom number or smaller than it. It can never be bigger than it. Okay? And then, if it could never, ever happen, this is the third bullet here, when an event cannot possibly occur at all, no chance whatsoever, the probability is going to be 0. Okay? When the event is going to be certain to happen, it's guaranteed no matter what. Instead of saying 100%, the probability is going to be a 1. Again, just like percents, we're going to move that decimal place over 2 spots. So when you look at all the probabilities, all the chances when they get added together, just like when you're adding up all those fractions and everything else, it will always add up to equal 1. Because all the options put together will be 100% chance. that one of those total options will happen. Okay. I'm not going to worry about this one where it says for any event, EPE, that sort of stuff. Kind of gets confusing when you're looking at all that. So let me kind of get down to the example down here. Okay. I've got of the next 32 trials, let me get myself some room here. Of the next 32 trials on a docket in a county court, 5 are homicides, 12 are drug offenses, and 6 are assaults, 9 are property crimes. The jurors are all assigned randomly. What's the probability that a juror or a given juror will not get a homicide case? So the first thing I need to do is I need to figure out how many total cases there are. There's going to be a total of 32 cases. And it's doing that thing again. All right, I've got a total of 32 cases. When I look at all those cases, I know that they don't want it to be a homicide case. So I'm going to say out of all those choices, there's 32 choices. I know I don't want a homicide case. So I'm going to subtract all the homicides. So 32 minus 5. If I get 32 minus 5, I've got a probability of 27 over 32. So probability of not homicide. Oh my goodness, that's annoying. So probability of not homicide. Let me figure out what's going on here. All that stuff go right back up to the top again. The probability of not homicide, and now my bottom number is gone again. Let me just try it from over here. We'll put it right on this side. So again, I have that 32 minus 5 over 32. That told me it was 27 over 32% that it's not homicide, which tells me that there's an 84% chance that that juror will not have a homicide case. The good news for you is I'm about to give up on writing if this thing keeps on doing that. All right. So that first part was talking about the classical probability, which is usually referred to as theoretical probability. The next one is going to be empirical probability. So that's based on actual observed samples, the number of times that it has occurred and a certain number of trials that have happened. Okay, so how many times you actually saw that happen out of the total amount. Okay. So looking at this one, I'm going to look at this one and hopefully my screen works along with me. And if not, I might just put it on a brand new page. Actually, I'll probably put it underneath it. It says in a sample of 500 people, 210 have type O blood, 223 have type A blood, 51 have type B, 16 have type AB blood. Set up a frequency distribution and find these probabilities for a person selected at random from the sample. So I'm going to go through and I'm just going to make a little chart here. Hopefully this thing likes me today. Or at this point, I got blood. And I've got the number of people. I've got type O, I've got A, I've got B, and I've got type AB. So I've got 210, 2, 2, 3, 51, and then 16. Add it all together, every single one of those, there's a total of 500 people. Okay? So this is going to be how I'm actually going to distribute all of my data. So looking at problem A. A is going to say the person has type O blood. My total amount of options is going to be 500 options. 500 options, and I've got 210 right here. So to figure out my type O blood, I'm going to divide 210 divided by 500. It gives me a 42% chance that a person's going to have type O blood. Problem B, It says a person is going to have A or B. Probability of A or B. And it's doing it again. A or B, looking at that, I'll have that 223 plus 51 over 500. Because again, I'm getting this number here and this number here, the A or the B, which is 274 out of 500. That's going to give me 55%. Again, if it says either of those, it can be an added together sort of situation. Okay, and this is kind of like what we did with those Venn diagrams. So for C is looking, the person has neither type A nor type O. So it can't be A, it can't be O. So I'm going to look at the stuff that is not the type A and the type O. I've got 51 plus 16, still over 500 because that's the total amount of examples. So that gives me 67 over 500, 13%. And the last person, it says D, this person does not have type AB. So I can do not type AB. I can take all those. So 2 of 10 plus 223 plus 51 over 500. Or I could even take, because I just know that I have to get rid of that one specific type. So 500 minus 16, all that's going to be over 500. Because I just have to get rid of those 16 people. Okay, if I subtracted those, put it all together, I have a 97% chance of getting a person that does not have type A blood. All right. To get into kind of doing that March Madness stuff that we talked about yesterday in class, we were talking about all those games that we had going on, where we had that septillion choices to try to figure out all that stuff. So anyway, I'm going to kind of talk the 16 seed versus the 1 seed. So when we're looking at all of those groups that we had, okay, the total amount of meetings. So I'm going the March Madness bracket. So March Madness, when we were talking about all those ones, we had 2 teams and only 1 winner. Okay, so 2 teams down here, only 1 winner. So if I'm looking at the classical probability, so that's what this one is, I'll say it's the classical. There is a 50% chance that either team is going to win. Okay, on paper, it looks good. But if I look at the empirical, where I have that 16 seed versus that 1 seed, in total, there have been a grand total of 144 total games between a 16 seed and a number 1 seed. Out of all of those games, only 1 has ever beaten a number 1 seed. So from there, I'm going to take that 1 divided by 144, and it's going to come out to, with my empirical, I've got a 0.7% chance. 0.7% chance that the number 16 seed, I'll say 16 seed versus the 1 seed. So again, that's kind of where that difference between the classical and the empirical actually is. Classical is, in theory, that's what it should be. There's 2 teams going against each other. One's going to win, one will lose. Empirical is going to be the actual data of all that stuff that's happened over and over and over again, over multiple trials. Okay? Hopefully that makes sense. So, all right, your assignment is going to be page 644. Numbers 23, 25, 27, 29, 37, and then 45. All right, you guys have 6 total questions for your assignment tonight. Just dealing with probability, you're going to deal some classical probability, and you will deal with some kind of the empirical probability, where they actually have those experiments and they actually have numbers that go along with it. So 6 questions that will be due on Thursday. Thanks.